Right. Well, yeah, thanks, Sebastian. Thanks, everyone. So yeah, I'm Steve Dorton. I'm going to talk to you about wargaming with the social and cognitive sciences. So I'm going to talk a little bit about, basically how the wargaming and ops research community, as well as the social sciences community, whether that's experimental psychology, other behavioral sciences, really should be working together more tightly because there's a lot of benefits to be had from doing that. So I'll go ahead and dive into this. So like I said, I first want to provide some grounding and perspective, kind of who I am, where I'm from, coming from. I'll talk from kind of both angles, the value of war games and TTXs or tabletop exercises that they have for social sciences or social scientists, and then coming the other direction, talk about the value that the social sciences can bring to war games and tabletop exercises. And then I've got two kind of case studies or examples of ways where we've taken war games or tabletop exercises, we've mixed them with human factors engineering, systems engineering, other types of social sciences, and come up with something kind of unique and ultimately helpful. So, and then open it up for discussion. So, we've got a lot of time. What I'm going to probably do, unless there's any objections, which I don't think there are, I'll probably get through each section and then kind of pause for Q&A there rather than I don't think anyone wants to listen to me talk for an hour straight. So we'll break it up as we go. So again, just to provide some grounding and perspective, I'm Steve Dorton. I'm the chief engineer for the Social Behavioral Sciences Department at MITRE. I'm up here in Bedford, Mass. I also am an adjunct lecturer at the University of Maryland in the School of Public Policy. So I teach, it's a mouthful. It's social, ethical, and policy considerations for AI and big data systems. So not just AI, but the data as well. Thinking about the societal implications, things with sociotechnical systems, et cetera. I have about 15 or so years doing human factors, research, development, test, and evaluation in the context of defense and national security applications. So I've been very fortunate over the years, worked on probably a couple, hundreds of programs. I would boil them all down to those two bullets, which is really looking at understanding cognition, how people make sense of things, make decisions, etc. And then ultimately to develop some type of decision support capability. So whether it's some AI enabled thing, a better visualization, changing workflows themselves, etc. Things like that. From an education perspective, my background, I have degrees in human factors and systems. So again, half experimental psychology, half systems engineering. And my undergrad's actually in safety science, which is kind of like occupational safety and health. The other bumper sticker on the right here, I think, is kind of a potentially important thing, which is I actually don't really identify as a wargamer. I've been involved, if you count individual games, probably north of 100 games or TTXs, tabletop exercises. But I don't consider myself a wargamer. I consider myself a social scientist that loves war games, and by love, I mean, I see the value in and make use of them in the type of work that I do. So again, it feels kind of interesting or kind of odd, like a bit of an interloper coming to a wargaming society and talking about wargaming when I don't actually really identify as one. I just kind of stayed at a Holiday Inn, so to say, or I work with wargamers quite a bit. So, again, I'll talk a little bit. I want to talk a little quick primer on naturalistic decision making or NDM, mostly to explain kind of where I'm coming from, and I swear I'll get to the wargaming at some point, but I just want to kind of frame where I'm coming from, the kind of work that I do to show, again, provide context to some of the arguments that I want to make here. So again, I am a card-carrying member of the Naturalistic Decision Making Association. NDM, you could think of more casually as kind of the study of how people actually think. So when you think about a lot of psychology research, things on like judgment and decision making from folks like Kahneman, Tversky, um, a lot of psychology research is done where it's in a lab, it's in a sterile lab environment where you control for every possible variable. And so in the NDM movement, there's a big focus on expertise. So again, you have usually undergraduate students in weird populations, right? Like white, educated, industrialized, democratic. You have specific people that aren't actually experts at a job. You give them a fake task where you're trying to remove any expertise they have or knowledge they have ahead of time to get at some type of isolated phenomenology. On the other end of the spectrum there, on the NDM side of things, we like to study things in the context of expertise. That's how people actually make decisions. If you think about things like in defense, you don't have random people fly fighter aircraft. You don't have random people sit as the tactical action officer on a ship. They have training, they have experience, they have been qualified in a variety of ways. So the ideas of the NDM movement is to look at expertise and how expertise drives decision making. Um, there's also a big focus on descriptive models versus normative, and so descriptive being descriptions of things that have been observed, the ways that people do things, work as done, and you can think of normative as work as envisioned. So again, um, there's a big emphasis on, again, the thing about the good way to explain this would be, say you're driving in Arlington, and that works for whether you're in the Massachusetts area or the DC area, about the same, type of landscape. But you're driving in like rush hour, almost rush hour, and a kid chases a ball into the street in front of you. A normative model of decision making, like a multi-attribute decision making, model might be enumerate all your possible courses of action. You can slam on the brakes, you can swerve, you can, I don't know, hit the gas, speed up. Um, hopefully no one really thinks that. Uh, and then you would say, okay, for these course of action, these are the variables or the factors that matter. So damage to myself, my life and limb and safety of myself, the kid, traffic, damage to my car, whatever. And then you would say, what are the relative weights of those factors? And then you would assign weights. And then you would say, well, what are the actual, what are the weights? Like, what are the values of those? And you could do like an expected utility thing and say, okay, the optimal decision here is to swerve. No one does that, right? Like, if you're making split-second decisions, what you do is the descriptive model would be like the recognition prime decision model, where you would think about things that you've done in the past in similar, sufficiently analogous situations. If not, you might do mental simulation, but you make satisficing decisions. You make a satisfactory course of answer or course of action in the least amount of time. And so again, like the NDM movement looks more at descriptive things versus these idealized normative models. And so there's key theories for sense making, for decision making, for even insights, how people have aha moments, all involved with very uncontrolled field work to understand how this stuff happens by experts, real users, and real tasks. And so there are challenges, as you might imagine. A colleague of mine, Brian Munch, did a presentation talking about how when you do this kind of work, things are usually either like with the military, usually sensitive, or they're proprietary to a company. So it's really hard to kind of get NDM work out there. But there are a lot of logistical difficulties. If I want to study, I'll go to submarines a lot during this presentation. But if I want to study decision making on a submarine, it's really hard to get me out on a submarine. Um, and it can be a tough sell. I think Gary Klein, who's kind of the father of the NDM movement, has, in one of his books said that a program manager said with hindsight, they never would have funded, Charles Darwin's study which drove the theory of evolution. So, it's a tough sell, and there's a lot of logistical difficulties with danger, cost, etc. So you can probably see where I'm going with this with regards to war games. So one of the key values, again, this is how war games provide value to social sciences and behavioral sciences, is that they provide a low cost, low risk way to do field work, right? It's a hard sell to do that anyways. They're very effective and efficient, meaning, effective, they get you the result you want, and efficient, they do it with very relatively little effort. So I'm not going to go like word for word in this, but this table is from a paper that I'll share at the end. But there's a lot of ways you get a lot of bang for your buck when doing war games and TTXs. So you can get explicit capture. You can actually have people document their stuff in move sheets. So the decisions they make, the factors that are important, the utilization of weapons, sensors, things like that. There's also opportunity for observational. As they're doing stuff, you can passively see how they react to things, what artifacts they use or don't use. Often we use war games to test whether some new technology will do something. You can kind of observe that passively. There's also freeze probes. You can pause the gameplay or take a break at certain phases, or something I'll talk about later that uses freeze probes. Exactly what we're talking here. And you can present people with questions, challenge assumptions, do things like that. And then, of course, the hot wash after certain rounds, like say in strategic games, you wouldn't want to do this for like a Kriegspiel, but after rounds, you have questions, and facilitated discussion, certainly after the game itself. So, and it's not field work, but it's also not theoretical. We're not having a survey saying, what are your biggest priorities during X, Y, or Z scenario? We can actually watch what people do when they're making these types of decisions in a relatively, contextually rich environment. So again, in practice, you wouldn't actually do all of these things at once. You need to kind of measure. You don't want to break the pacing or the flow of the game or make it really boring and ruin kind of the morale. But you have a lot of opportunities as a social scientist to collect data and gather insights. So I think they're fantastic ways that give you a lot of options. And so just one case study to talk about real quick. There was a game. There's a report out there about Sage Dragon. It was a Matrix war game focused on strategic competition in a certain region. And one of the goals was to enumerate novel levers, so a research-based objective. What things can be done that might have an impact on strategic influence? And so, as far as the outcomes, we were able to identify novel levers, so succeed that research objective, but it also provided a lot of insights for decision support as well. So a goal wasn't to make some kind of dashboard or doohickey that does something. But even watching, people were getting out butcher paper and were making timelines. They were making kind of conceptual maps. They were making branches of different things. So we were able to actually see what they were doing on whiteboards and things like that. And again, if I was in the business of or had been tasked with designing some type of decision support capability, that would have lent me to some requirement specification, design seeds, perhaps some test cases. So kind of the notes at the bottom, I think from a social sciences perspective, again, they provide a lot of ability to support both research and development. So if you're going in for studying phenomenology, you're still going to get some value towards what types of tools or implementations or artifacts would be helpful, and vice versa. If you're going to study or design something or have kind of a design or development based objective, you're also going to learn a lot of other things. And the last bullet here is something perhaps worth talking about. I'd be interested in what folks online have with that. I'd love to get it funded to do something more systematic, but there's something that we coined in a paper called soft benefits, which are we kind of define as the things that you didn't state you wanted to accomplish a priori, but just happened from having a war game. So relatively intangible things. So like you get to, meet teammates or increase morale, develop a working vocabulary around some type of new mission or phenomenology. So in addition to the research and development angle, there's also all these other great benefits that come from these. So this is all part of a paper we wrote in 2023, talking again like, hey, social scientists, war games, TTXs should be in your toolkit. Look at all these great things that happen from them. So to flip that around, what's the value of the social scientist? Why should wargame folks, operations research types get involved or involve social and behavioral scientists into their work? Um, and one way really is at least myself and other experimental psychologist types that I work with tend to treat war games like a psychology experiment. It's one thing we do from schooling through our careers. We're very used to designing experiments to test certain things, to measure and evaluate things that come out of them. So a couple things can happen. One is alignment to relevant theories, right? So I have a whole slide on this coming up, but you say you want to do some type of high level thing. Social scientists can align that to different theories or constructs, which then open the door to measurement and getting richer, more valid and rigorous data out of that. Um, and we can also help map objectives to data. The thing on the right is something I actually made for somebody, got brought in to consult on, they had done a game or a series of games and said, okay, we have all the data that anyone's ever done. We have like keyboard level interactions, chat logs, you name it. And they said, okay, we want you to help us do this. And I said, well, what are your, help us with analysis. And I said, okay, well, what's your analysis? What are you trying to do? What are your objectives? And they said, well, we want to know what tactics are most effective at doing this thing. Said, okay, well, like, what are your research questions? Like, do you have any hypotheses ahead of time? And in that case, it's no, it's exploratory. But the diagram on the right is just a concept map showing again the way that psychologists and social scientists tend to view this is you have objectives that you have research questions that go to answer the main objectives. If you might have a hypothesis or not about that, there's certain inferential and descriptive stats, and then you can kind of again trace it back from here's the high level thing you said you want to do, all the way down into the weeds of what raw data or intermediate or fused data that you need to create to answer that. And again, I want to say too, as I talk about a lot of these things, these are kind of like success stories from getting brought into war games. I'm not trying to imply that wargamers don't do this stuff already. I don't think it's a binary outcome kind of thing, but the more that you get social scientists involved, the more this kind of stuff tends to happen. Don't want to be casting aspersions on anyone here or painting with a broad brush. Um, Another thing that I get brought into a lot is for like a data collection and analysis plan. So again, treating it like a big social science experiment. Things that social scientists do a lot of, things like interviews, surveys, those are like our bread and butter. So doing pre, during, or post game interview prompts, things for observers to look for, survey design as well. Things like people do have a lot of experience in psychometrics. Not that you need something that formal for a war game, but again, designing surveys, um, even writing requirements or designing, instrumentation or passive capture, and also figuring out what things need to be answered with which of those buckets I just talked about. Kind of again, balancing them out, saying, here's what you want to know. These things are better suited for, say, behavioral measures, what they actually do versus what they say. Some things are better for them to verbalize. So also balancing these things out, again, not to ruin the pace of gameplay, while also getting you all this rich data that answers all these things that will drive ultimately a great after action report or whatever the analytic product is that the sponsor desires. Um, and the last two things I have slides for that follow, but two things also that I think social scientists bring to the table when we work with war games are improving the tradecraft itself, can help actually do some continuous improvement in those regards and measure squishy stuff, which is something I'll talk about and kind of decompose here in a second. So this is just one example of where we evaluated kind of the tradecraft or the methods and the tools of what wargaming was doing. So a previous part in my career was looking at we were doing a whole series of tactical war games, looking at different how different things might affect you might have co-evolved tactics with new technologies or things like that. And we basically said, hey, this is like we're in the 2010s, we shouldn't be doing this manually. So at the top right is what we were doing. It's something we called, the low resolution simulator. And it was basically people doing, drawing out, lines, doing target motion analysis, manually moving stuff. We had these are exemplars for the purposes of publication, but we had like overlays for different look angles for different sensors and weapons and things like that. And we said, you know what? There's a lot of time being spent rolling dice, using speed strips, doing this stuff. We should make it digital, like, and that way we can kind of speed through some of this. And so that's what yielded the medium resolution. I don't think, people thought we'd call it high resolution, but we made the medium resolution tactical simulator. And so what we did was, and by we, I mean like a bunch of human factors, user experience types. We did was we actually made a observational data prompt. So we said, here's things that observers in each room should look at with regards to what the people running the war game are doing, what the participants are doing. We use surveys with the participants as well. And so what we found was there was a significant difference in the perceptions of gameplay being faster and smoother. For example, like, hey, there's less time spent on overhead calculations. You're not doing time, speed, distance math. So the perceptions went up. So going digital really helped in that regard. Uh, but we got what we what's the saying? We got what we asked for, but not what we wanted. So what we also found out though from the observational data. So again, if you ask people about, hey, does this new technology work? Everyone's like, this is the best. It does. But we also found there were some caveats to that. So we had a less hands-on approach. So again, in the old version, you have a room of 6, 8, 10 people. Everyone's hands-on, pitching in, talking smack to each other about, their, how their target motion analysis is good or bad. Um, and then what it turned out was it was now projected on a wall in a room. One facilitator ran the computer, and everyone sat in like a movie theater style seating looking at the wall. And what we found was, yeah, it was more efficient, but that meant there was less time to discuss. And the whole point of this was to learn about their perceptions, their assumptions, the things that they were worried about, that rich context. The whole point, like I've been saying, of war games, you get this great contextually rich dialogue that gives you all these insights into behavioral phenomenology, into designing technology, into tactics, con ops. And so, yeah, we sped it up, but that meant there was less discussion about the things that we cared about. We also found it was more focused. So people were um, not discussing all the different things. They were talking about the next move and what they were going to do and what they needed to feed basically the facilitator at the computer. Um, we also found that people still had to get out of their seats to trace. So if you do like, hey, I want to think about a question mark. I want to go up and then kind of curl around and then come around slowly. Now, instead of you being able to trace that on the table, you're trying to explain that verbally back and forth with someone on running a computer. So we found that people had to get out of their seats anyways to kind of trace it on the wall and show what they wanted to do. We also found that people used to take notes and either write them on dry erase or put them on sticky notes on the thing, and we take photos at each turn and record it. And so now people, because they weren't at the table, they were taking notes in their own notebook. So we also lost that kind of collective intelligence angle where we were getting all this great uh, observations that were mediated by all the tacit knowledge and expert knowledge that was at the table. Different perspectives, different types of operators, different kind of tactical decision makers, different engineers and scientists. We kind of lost that a little bit. So we also had other notes too about like the tool itself, other kind of human factors, engineering or user experience issues. Like what was automated was things like, speed strips or looking at things, but you still actually had to manually calculate, based on course speed, depth, etc. You had to move the puck on the thing. So we also noted, hey, like you wanted to speed things up, maybe not the thinking part, maybe about the part where you type in the commands and it just moves the puck. Um, so again, we in summary, we got the efficiencies in the game, but it detracted from the discussion and the learning, which is kind of the whole point of the game. And it's something that again, like without a bunch of I guess bored social scientists around, otherwise might not have been discovered. And so this is still useful when you want to run stuff to ground and be less exploratory. This is still very appropriate. But again, we were able to kind of look at the Tradecraft and say, here's where it's appropriate to use these types of tools or not in the campaigns and the kinds of things that are being ran. And then finally here we talk about measuring squishy stuff. And so I've been kind of an in joke within my own department. We've been kind of joking about maybe making this like an unofficial motto. It's something that we do an awful lot of. So this is just an example where again, I get called into a war game or tabletop exercise, not usually to be the one to design it, not to do game mechanics and write the road to war and things like that. But usually to do like data collection and things like that. But what'll happen is the first thing I say is like, what are your research questions? What is it you want to know? When we execute this and write up some kind of product, what is it that you want to have answered? And so we'll get stuff like this. And this is actually something that one of my colleagues did not too long ago. And they said, well, this is like a collaborative multi-team kind of thing. I want to know if people are on the same page or not. So you might have this kind of construct in your head. And so that's the request we'll get. And we'll say, oh, okay. What we would call that is shared mental models. That's a body of work that's been going on since the early 90s. NOC TSD, the US Navy did that. There's a lot of literature. And in fact, there's a lot of methods and measures and metrics for shared mental models and how it affects team building and team operations. So, we can do applied concept mapping, we can do card sorts. Some of these are more or less practical to be implemented in a war game, but again, you have this kind of high level, imprecise idea of what you want to know. The kind of things that social scientists can bring to bear is again these existing constructs and these other methods and measures. And so similarly, we get stuff like, well, I want to know how much better are their decisions when they have this new, X, whether it's new information, new sensor, a new network that, gets more sensors, whatever. Right. I'm sure a lot of folks have probably been in this scenario, right? This is a really common reason why we war game. So again, we could say, well, not even decisions, but like, is it really SA? You talk about domain awareness or battle space. Is it really SA, situation awareness? And there's multiple levels. There's level one is perception, there's comprehension, projection, and there's all these existing measures, many of which are freeze probe methods. So actually, we can bake this into the game really easily, like the situation awareness global assessment test. And also say, well, and to get to your original thing, is it a judgment thing, like how they're judging things? Is it decision making, what they do with those judgments? And we have all kinds of outcome and process-based measures. So accuracy, like in a signal detection theory kind of context, like type 1, type 2 errors, is it the speed of decision making, et cetera, or process-based measures. So outside of the outcomes, but are they making use of this new information? How much are they actually relying on it in their decision making? Are they using more of the resources available to them because now they have this other stuff they didn't? Are they communicating with their teams? So again, there are constructs and there are various methods and measures, and these are things that we work with, all the time that we can bring to bear and find really non-invasive ways and pragmatic ways to measure them in the context of a game or like a tabletop. And so the other thing that the bumper sticker at the bottom is, we often create bespoke measures. So to be a little self-effacing, experimental psychology doesn't always make things to be super useful or pragmatic. So if it's like, hey, there's this great validated scale for team constructs, and it's a 37 item survey. Obviously, that's insane, and you wouldn't want the players of a game to do that. Certainly not regularly throughout a game. But again, we can do things, look at them, and synthesize them in a more valid way to say, okay, I actually have a 5 item thing that takes less than 10 seconds to fill out, 20 seconds. And now we can afford to do that every round. And now we can actually see where people are divergent or convergent, and when certain key events happen, who gets on the same page. And we can kind of create these timelines that go and can be annotated or overlaid with key game elements. So we make bespoke stuff all the time to help war games out. Um, and then also, like, what about cognitive workload? What about trust? Those weren't even mentioned, but those are things that, again, you might want to consider. So what often happens when we bring in new technologies, new sensors, new information, it can overload people. So, hey, what about like the NASA TLX, the Task Load Index? There are really simple, simple, quick ways to assess if their workload was higher. If you run the game one way and then run the game the other way, with or without this new information. So there's in Trust, there was a program, a game I supported a little while ago that said we have this cool thing, and we don't know why people do or don't trust it. And so what we want to do is we're going to give them a survey and ask them like what their like risk percentage is, what risk they're willing to take, like a 0 to 100. And we're like, what does that mean? And so we actually wrote up a pre and post survey, and we did some observational things to look for, and some think aloud stuff that was in the hot wash. And what we were able to do is take an entirely qualitative approach, which I think was foreign to a lot of the folks that were trying to do it. Thankfully, they trusted us, and we ended up getting some really good insights. I can't really share that here, but again, we were able to come in, listen to what they want at the high level. I want to know why they do or don't choose to use these types of things. And we were able to actually kind of, again, walk through the relevant constructs, what kind of measures there are, and how to collect that data and design the data collection analysis plan to do it. So sometimes we'll think of things that are really relevant and kind of like free bingo spaces. They don't really take a lot of effort, but we can even get more insights than what was originally being envisioned. So I'll stop there. I don't know, Sebastian, are there any questions or things popping up thus far?
So there are two questions. It says the decision making of pilots are heavily studied. Are there any similarities or differences between submariners and pilots, and any cognitive hacks or discoveries from submariners? That's very specific to your example.
Yeah. Um, there is let's see, I'm trying to think here before I speak. I would say first that I'm not an expert in either. I've worked with both. I've worked with submariners far more, but I do have a background in aviation as well, both military and just general. I would say, I'm trying to think here. I don't think I have a very smart thing to say about that. I would say that submarines are possibly more deliberate. I would consider, they move slower than airplanes. So I would say there is, not that there's not a lot of complexity in both domains, but I feel like um, submariners are constantly replanning, and there's just an immense amount of context. So I would say, um, based on like crew resource management, other common, things in aviation, there are a lot of cues and things you look for, and you can make quick heuristic based decisions. My amateur opinion would be like minor league, professional but not good. My minor league opinion would be that um, submariners seem to engage in more sense making versus decision making. It's a lot of fusion and synthesis of different things and making very highly complex, highly dimensional decisions. Again, not that aviation doesn't, but I don't know how to describe it. I don't know if that's articulating it very well.
The other question says, are war games like Sage Dragon that you mentioned open to broad participants or specific communities, or is that like invite only? I sort of know the answer, but I want to hand it over to you.
Yeah, no, that was something that was already done. And so there is, if you Google like MITRE Sage Dragon, there are some publicly available products talking about the outcomes of that. And I can't see who's online or not. I think some folks who were involved in that game might actually be online. Maybe if they want, they can put something in the chat. But that was something that had already happened. It's not, to the best of my knowledge, a regularly occurring thing.
That's all the questions we have at the moment, so I think you can press on.
Cool. Okay. All right. So what I'll do is I have two sections here. Two sections here. One is going to talk about Wake. So how a bunch of social scientists teamed up with wargamers to develop a way to identify requirements for a user interface for a novel system. And then the other one I'll talk about is looking at an example of, again, kind of infusing some of the sciences into tabletop exercises, looking at sociotechnical system resilience. So, um, quite a mouthful. So we'll just dive into this one first. And so the way I frame these two things is I kind of have like the overview and challenges, what the approach or the goals were. Then I'll walk you through what the game or the structure was and some of the outcomes. So, um, for this one, just for the overview and challenges, we needed to design a HMI or human machine interface for a novel system. So I don't mean like an incremental improvement. Like this was a pretty wildly different thing. So one of the in the paper that we wrote about this, what we said was like think about like the first smartphone, which maybe not the first one. Because I was prepping for this and found the first one was like 1992 and didn't have a lot of things. But think about like the first iPhone. Like how do you say what it should or shouldn't have or what it should do and how it's going to be used because no one's ever used one before. Um, and so our challenges again was extreme novelty. There is a high variety of use, so this thing was going to be used in multi-mission, very different types of missions. Um, and then also there's limits to different elicitation methods. So knowledge elicitation being kind of a blanket term for how you get expertise out of people's heads so that you can do stuff with it. And so things like the critical incident technique, critical decision method, they all rely on people who have done things, again, in a very naturalistic setting. This thing or anything even sufficiently analogous doesn't really exist. And we had to work fast. So they were doing, agile or scrum. So when we look at this is more of a methodological note for like human factors type folks, but we do big things like the task analysis that can take several months. And those are big foundational pieces of work that we use to write requirements. We can, develop design seeds and mock-ups from them. They identify test cases. They affect almost every part of the system's development life cycle. And so when you're doing waterfall, like at the bottom of this diagram, that's good. You have requirements phase on a ACAT to on certain acquisition category or certain size projects. They might take 6 months, they might take a year. So if you do your work in 4 or 5 months, you're still providing that warfighter feedback into the system. However, if you're doing sprint or agile, they might be on the fifth or sixth iteration by the time you've had a single input. And so that's a good way to kind of get left behind and stuff does get worked in, but again, inertia builds as things get built up, the longer it takes you to get your input in. And since when our input here is advocating for warfighters who do important jobs, very stressful jobs, we want to make sure that we're advocating and getting their inputs in as early and often as possible. So um, yeah, we need to work fast. That was also fun because we got to write and use the term FOMO in a journal article, which was kind of interesting. The fear of missing out. So what happened was we ended up getting what I like to call like the middle school dance between the engineers, the developers of the system, and the warfighters. And so what happened was we'd go over to the engineers. We were working with both the vendor, the people developing the hardware, the software, whatever, and we were working also with the organization that develops tactics, techniques, procedures for how to use this. And so we'd go to the engineers and we'd say, okay, well, like, what are its capes and limbs? Like, what can it do? What can it not do? And they'd say, well, there's a lot of trade space. We can give you more of this, less of that. We can swap out stuff. And, what do you need it to, what's most important to you? How's it going to be used? And we're like, I don't know. I don't know. I'm here to design the interface. So we go back to the war fighters and say, hey, like you're the tactics shop. What are the tactics for this? How's it going to get used? And they're like, well, I don't know. What are its capes and limbs? What can it do? So it was kind of like this awkward middle school dance where like all the boys are on one side of the gym, all the girls are on the other, just staring at each other. Someone's just got to get out on the floor and start dancing and get the party going. So um, we kind of jokingly said it was like Cunningham's law mixed with wargaming. If you're not familiar, Cunningham's law is in the context of the internet is the fastest or best way to get the right answer is not to ask a good question, it's to post the wrong answer. And so, taking some liberties as, like at the time, like, young engineer, never served a day in their life. I'm like, okay, well, I think it's going to work this way. So people won't tell you what they want, but I'll put something out there and let them, put a straw man out there and let them attack it. So that's what we did was we said, okay, well, this is the capes and limbs it's going to have. How would you use it? And we did this series of games. They say, oh, this is terrible. We really need more of this. And we'd check with the engineers and they'd say, yeah, okay. So we decided to do this through gaming. So we made this thing called Wake, War Game Augmented Knowledge Elicitation. Like I said, knowledge elicitation is kind of like a blanket term for interview methods, focus group methods, ways to get knowledge out of people's heads. So we really embraced the concept of learning by doing, which has roots in like industrial engineering from the 60s, that the idea of, do a couple that are suboptimal so that you can figure out as you go. Kind of avoid paralysis by analysis. There obviously is a very long tradition of using war games to develop tactics, techniques, procedures, concept of operations. That we're not asserting anything is new in that regard. We wanted to build on that tradition and take a pretty inexpensive and simple approach versus some kind of really well-developed simulation or something like that. So again, our goals here was to be able to provide insights without relying on existing operators or existing human machine interfaces we could borrow from. We needed to enable this concurrent, so parallel development of the interface, the operator workflows, how they're going to actually do it, then also the tactics. They're all highly interdependent, and we need to assess cognition under different missions or context. And this all need to be planned, executed, and analyzed in weeks. So again, if you talk about like a task analysis, or you talk about, um, and again, task analysis is a blanket term, so there's a lot of arguments there. I know a lot of colleagues that would throw the flag on that comment. Um, but even like running a big modeling and simulation effort, you can't turn that around in weeks. So we developed this wake method, and I'll just kind of walk you through what we did. So it was basically a Kriegspiel that we broke down into phases with different freeze probes at each phase. So I mentioned freeze probes earlier. That's any in the psychology world, any method where you stop what you're doing. You can maybe cover things up so they can't see it, and you kind of quiz them on it. You can ask them questions. And so what we did was, let's say you could take like the detect to engage cycle, what is it, the F2, T2, EA, find, fix, target, track, engage, assess. Surprised I got that. Um, any arbitrary number of phases, but we could just say like, it's pre thing. Phase two is, let's say, like, pre-engagement, engagement, and like post-engagement. Let's say that. Um, and so what we do is we break it in those phases. We have them play the war game itself, and meanwhile these I's and A's here, these are information. So what we did was we had big canvas, those 2 foot by 3 foot sticky notes, and we had the little normal ones. And so us, the researchers, as they were talking, we would passively write down any information they were using to make decisions. And so we would jot all that down. And right when they were about ready to like do the engagement, we would say, okay, what is um, let's pause, let's time out. Did we get this right? Is this information right? Um, okay, yes or no. Sometimes we get it wrong, we misheard things. What other information? Like, this is one idiosyncratic use case, but what other information would you, typically consider? And we'd also go through assumptions. So when they ask the game master, what's the weather like? And they say, well, it's sunny. We would jot that down and say, okay, assumption, really permissive weather. Um, Assumptions on capes and limbs of the technology, of the environment, whatever. And so we would pause, we would explicitly do a knowledge elicitation freeze probe, again, clarify information, elicit other information, and then ask for different assumptions that they were making. And we'd go and we do this and we'd repeat it for each phase of the mission. So again, like in this example, this hypothetical, pre-engagement, engagement, post-engagement. And again, it could be any phase you want. And then what we did was we did participatory analytics. So instead of us analyzing it, we had the warfighters or operators think aloud and drive the analysis themselves. So it's really just a bunch of sorting activities. This is kind of anticlimactic. There's nothing really special or super complex here, but we basically had a recording equipment. We said, "Hey, y'all, please think aloud amongst yourself. You know, give the governor a harumph. Let's make sure to harumph a lot during this and speak everything you're thinking." Debate with each other. We want to know all the context, the pros and cons. But we just said, okay, take all these sticky notes in each of these phases and just sort them. What information would you want to get from a human machine interface, like the computer console you would use? What information would you get verbally? Like, there are certain procedures where you call stuff out in like operation centers. What stuff would you just prefer not to have in front of you, but to hear? And what stuff would you want to get from another display? There's all kinds of displays everywhere. So what needs to be in front of you versus somewhere else. So again, super simple, but have them talk about why they would or wouldn't want certain things. We then did a 2 by 2 matrix. So we have a matrix with criticality and frequency. So we basically would say, hey, for these three phases or X number of phases, everyone pick your top three, your top four. We want to get about 20, 25 items. Say, pick your top three or four most important things. So all of them are important if they're on there, but put them over here on this grid and sort them by how relatively critical they are and how frequently you would use them. So the top is like, anything along the top is without this information, it is impossible to actually succeed at this mission. And then on the right hand side would be anything along the right wall there would be this is continuous. I'm using this information at all times or the mission will fail. And what we found was actually a lot of things got pegged up against the ceiling. So, in theory, this looks really cool, but in reality, we had kind of like a ceiling effect where everything was up there and it wasn't as, diagnostic as we had hoped. But the 2 by 2 method's a really common method. It's really useful. So again, we had to see how they wanted to uptake that information, take photos of that, understand that, and then say, okay, and like how relatively critical is this? How often do you look at it, et cetera. And the last thing we did was a temporal sorting. So again, if you had, more than three phases, this diagram gets really weird really quickly and probably isn't worth doing. But we could also do is say, hey, like when do you need this? So we have these three arbitrary, mission phases. Um, what do you need in phase one? What do you need in phase two, phase three? What do you need in both or all? And so again, there's a lot of implications as a human factors person. When you go to design some type of user interface, this is really valuable data. Because again, like things that are say smack dab in the middle, those should be on like a common header or something that's persistently displayed. The other things that are mutually exclusive could be tabs on some kind of sidebar. So hey, like, and I can do, from temporal order. These are the things I need. Once I do them, it might switch over to the next. So again, if you're in the business of designing tactical user interfaces or strategic, dashboards or whatever, these types of methods are really cheap, easy, simple, and they give you an incredible amount of insight. And like the note I had earlier was it's not really scalable. If you have more than two or three phases, this gets really weird really quickly. So we just drew like circles, like hand drew circles on a whiteboard, said, okay, now move those stickies over here. And so some of the outcomes of this, we were able to generate a really usable story-oriented set of documentation. So again, to pick on myself a little bit, pick on my discipline, not all applied psychology study write-ups are really easily interpretable by people who don't study this stuff for a living. That's I think a constant challenge is to communicate, especially qualitative studies. Numbers can be kind of like comfort food. It's easy to look at a survey result, but it's harder to kind of tell a story with 15, 20 interviews about what some warfighter needs or type of warfighter needs. And so what we ended up with was this really nice storybook, and we had pages. Each page had a picture of the game board at that time. We had the information that they were using, the assumptions that were being made. We had key decisions or actions taken, certain sensors, weapons, maneuvers, whatever. We documented all that, which generated a ton of requirements. So our initial goal was what are the requirements for the display for this thing? We had literally hundreds elicited in like two days or 3 days of gaming. Um, it streamlined the way that the human systems integration team got inputs into the requirements. Remember, we talked about the fear of missing out. We wanted to get those stuff done early. So I think by month 2 or month 3, we had hundreds of requirements. And I talked earlier about the soft benefits, right? So some really cool stuff that we didn't plan on, didn't aim for, but got out of this was a shared mental model among developers. There's all kinds of computer scientists, electrical engineers, mechanical engineers, et cetera, working on this program, with most of which don't have operational expertise. So being able to have this story-based artifact, they say, oh, this is what it is, how it would work, how they would use it, was really helpful for people. They built a shared mental model. And what we actually found was that the products we delivered became onboarding materials. So if you were a new electrical engineer that joined the project, they gave you this report of ours. That was how you learned what it was and how it was going to be used, and gave you kind of a sense of purpose. It also identified a bunch of edge cases. So before we do expensive human-in-the-loop testing, you don't want to waste like 3 or 4 lab days when you have warfighters flown in for something. And then you're doing like silly edge cases. And so again, doing war games, all this rich context and emergent behavior and properties, we're able to discover that and save a lot of time and money. Uh, and the other bumper sticker here is that Wake is fun. And so I don't just mean that to say like hooray, but when we talk about recruiting very busy people who don't have enough hours in the day to do what's expected of them, there's a big difference when we talk about data, recruitment and retention of participants. You talk about data attrition. It's a very different thing to say, hey, I want to interview a bunch of you about like a knowledge elicitation session for your requirements for decision support capabilities. That's a very different ask than saying who wants to come out and do some gaming for a couple days. We actually had people telling us, "Hey, like I'm gonna rotate out of this position in 4 months. Can you do the next one? Or in 3 months, can you do the next? When's the next one? I hope I get it before I get rotated out." People were actually like rock paper scissoring with each other of who got to come back and play what role next time. So again, for social scientists, war games are a really fun and engaging way to get the data that you need to design things or study things that you need to do. So I'll pause there. Any questions, comments, or amusing anecdotes maybe with any of that material?
Steve, I don't see any yet, so I think we can keep pressing on. Um,
All right. And again, we'll have plenty of time for questions later. Um, and so what I'll do is kind of shift gears here, talk about tabletop exercises, which again, from my worldview, I think it's a paper from I think Matt Caffrey. Talk about again, TTXs are just a type of war game without a thinking adversary, right? So also very important part of the toolkit. I find myself doing a lot of TTXs these days more than war games. But again, another application of this type of thing and how we can kind of fuse the social sciences with wargaming. So uh, what we were trying to do, again, coming back to the overview challenges kind of view of things, a big thing that happens when we make new software, new AI, new hardware, new gadgets, whatever, when we add new technology to a socio-technical system, it can reduce the resilience of it. So by socio-technical, I'll give you like a primer on resilience engineering here. So again, bear with me, we'll get back to the wargaming, but trying to explain the complexity and all this weird stuff we're trying to do. The thing on the right here we kind of call the cognitive triad. So a socio-technical system is a system that's comprised of people, technology, and work. And work's kind of a weird term, but that's SOPs, standard operating procedures, doctrine, tactics, even like culture, unspoken things, loose work agreements, stuff like that. So all of these things that come together to achieve some kind of goal or objective are a socio-technical system. And so you usually build technology to do stuff like improve the performance or improve efficiency or improve security. But when you do those often decrease resilience. You're kind of like solving or optimizing for like a local minima or maxima, if you will, but the whole thing is kind of suffering a little bit. So um, there's this framework called Trust. It's, transform with resilience during upgrades to socio-technical systems. I was fortunate enough to work on that project a couple years ago when I started here where I currently am. And there's what we call the BFFs, the big 5 factors. These are 5 factors, and there's all these sub factors. It could be like a whole separate 5-hour conversation, but the point is resilient socio-technical systems have these 5 things, right? So they have shared demand and deviation awareness. Each unit in the system, like people or organizations, are aware of changes in demands, whether it's typical, whether it's within nominal operations, it's just fluxing, or whether it's abnormal, etc. Progressive responding, the whole system can engage in continuous sense making, continuous decision making, and align itself to demands as they change. response coordination as being the mechanisms to have adaptive coordination of resources, being able to give and take among different units in the system. Uh, Maneuver capacity is like the diversity of means, or you could even kind of boil it down to redundancy. They can act in different ways, it can be novel to achieve goals. And then the last one is guided local control, which we talk about those work agreements, right? It's kind of like commander's intent. You might have higher work units can provide this kind of flexible guidance to the frontline units who then have the authority and the local control to adapt to things as they happen. So again, when you say like security, I'm going to make this new technology that increases security, but usually that involves locking something down and people lose guided local control. Or they're not seeing things they used to because this automation handles it. Now they don't have as much demand and deviation awareness, or they don't have the ability to do response coordination because this new integrated, chat client you installed. So um, again, the big problem is also proactivity as well, which I think I'll get to here. So really, when you build technology, it comes down to requirements engineering. Are you getting the requirements right? There's a lot of people that would argue that. I would argue there's a lot more, but at the end of the day, when you start specifying what some technology needs to be, that's kind of what's going to really have the most inertia for what the technology is going to turn into. So a big question is, how do we get technology development teams to proactively consider resilience? And a big problem too is we also wrote a paper about with some other folks about resilience engineering. A lot of the current tools require things to exist and already be kind of out live. So, the more proactive ones, um, don't require an accident or something bad to happen while identifying things, but they still require the thing to exist. So the question that we had was like, how do you, before the thing even exists, how do you steer it down the right path so where it'll do its stated objective but not adversely affect resilience? And so on the right is a big table, a bunch of challenges in there. But again, this is just showing how there are challenges acknowledged in doing requirements engineering with users. And there's also, there's a kind of a point counterpoint for why tabletop exercises are a good fit. So again, just to kind of summarize, hit some wave tops. It's just, requirements engineering, software engineering is increasingly distributed. Well, guess what? TTXs can be run distributed, they can be run asynchronously, etc. You need a lot of requirements engineering requires a lot of engagement with end users and stakeholders, but they're usually too busy. Like I just mentioned, we've shown that people are really highly motivated to participate in TTXs and war games. Gamified methods are really effective. There's a lack of common language and mental models of people. And again, TTXs and war games build those very things. Um, Again, like there's typical requirements engineering methods are too slow to be impactful. Again, we've already shown through the Wake example. I'm actually citing the Wake thing in there, but we can do that in a matter of weeks. And and finally, a lot of stakeholders and end users are concerned with their program, what's right in front of them. It's really hard to have kind of a vision forward, or at least to envision or entertain. You might acknowledge them, but not really explore future states or envision work. Again, I mean, TTXs and war games are great ways to look at alternate futures and how things might pan out. Excuse me. So, in the lower left, that's kind of what we said was, hey, we should be doing iterative, lightweight tabletop exercises that generate user stories. Another way of saying requirements, but user stories that support resilience. And on that project, there were separate efforts looking at how to integrate the trust framework we talked about into Agile, and there was another effort about how to use TTXs. And so we kind of said, why not both? Let's put them together and look at this solution. So what we came up with was RAD-XP, or it's the Resilience Aware Development Exercise Protocol. So again, we love good contrived acronyms, so we're doing our best here. But basically, this is it on the right. It's nothing too crazy, but we basically developed a turnkey protocol. It's like a 30 or 40 page document, how you can design, execute, and analyze 60 to 90-minute TTXs that would help proactively identify what could go wrong and how to design your system to support resilience. So we would have the things that have the yellow line around them is where the entire development team needs to be involved. The things that have the yellow dash lines is just where only a few key people. But we basically do this 2 week sense making period. We would meet and do document scans to explore the technology. What is the technology? What's it supposed to do? We would explore the work. What is the current or envisioned mission? Who does it? What are the goals? Success, failure? What does that look like? We would design the TTX, the inject, or the scenario, the overarching global scenario, and the injects, and then get it vetted by the team. The TTX took 60 to 90, it was 90 minutes, including the introduction and the hot wash, but the game itself was 60 minutes. So we would dry run it once on like a Tuesday, then Wednesday we'd run it, and then we had about, I think it took 3 days to do analysis, not even. So all this can be done in less than a month. So if you're doing, a 2-year program, every 3 months or something, you could do this with different injects, different scenarios. So we were trying to make this again where I did a lot of cognitive work with expert tabletop exercise designers, and then just basically said they took a lot of their expertise and codified it and got to kind of write like a guide of how to think like these people who've been doing this for 15, 20 years. It's kind of a cognitive work analysis of TTX experts. And so then we would, pre-process the transcripts from it, do the analysis, and we deliver this brief or this product that says, hey, here's the user stories that came out of your thing. And so this is the analysis. Again, kind of underwhelming, but I would argue simplicity is always good. But if you're not familiar, the Connextra template is kind of that format for user stories where it's, as a blank, I want to blank so I can blank. So it's, what user it is, what key function does the system need to do, and then what are they trying to do with it? And so the key here is we would really just look for verbs and then work forward or backwards. So you go through, scan through the transcript and say, where's an action that someone says they need to take? And so what it looks like here is, hey, like there's someone says I would want to, the verb here is to know if anything changed in terms of outcome. So, okay, that becomes the function. So I want to know if outcomes have changed since the last periodic review. We can kind of keep going down in the transcript to see if there's a rationale in there. There it is, to make sure we should still be using it. So that becomes, so I can make an informed decision about whether we should be using this tool. And then, looking back up, there's the user. In this case, the person was a chief medical information officer, so we knew that was their role. But again, very simple. You could even probably program some really simple stuff to go through a transcript and do a lot of the initial extraction. Now, I picked a really good one here for the article we published in, but in reality, sometimes the rationale is a paragraph or 2 paragraphs. But again, you look for the verbs and then just kind of visually scan, and there you go. So that's how a response to an inject in the TTX turned into a user story about how they can be this AI can make them more resilient rather than making them more brittle. And so I'll just spend like 1 or 2 slides here just talking about what this was. So this was an AI-enabled tool to assess fitness for maternal telehealth. So the idea is that for anyone who is pregnant, has been pregnant, knows someone who's been pregnant, there's a lot of trips to the doctor, right? And so the idea is that some people it's based on different social determinants of health, SDOH that's in there, might be able to do that. It might be easier or harder to get to the doctor. And so the idea is that these telehealth things can replace not all, but a lot of checkups for people who have low risk pregnancies. So the idea was, yeah, we're gonna make this AI that gobbles up all this novel research on social determinants of health as well as other classic clinical indicators. And this AI will kind of classify and say who should or shouldn't be doing maternal telehealth and any status changes. So we did the process I just described. In less than 2 weeks. We had these injects. We had this overall scenario where you're like the head obstetrician. I can't pronounce that right. And he had these injects. So just again, wave tops. Like your chief of medicine asks you to do a pilot study to figure out if it works. So that aimed at looking at like how would you know it's working, what measures would be important. Um, what happens if what if new research comes out and now, because the social determinants of health is a fairly new area, what if the actual criteria change, the things that underlie the AI in the system? Then, if it did change, how can you manually override this? What would you do? If you're not a software developer, what do you do with this thing? How do you manage your practice while that's happening, or your patient list? We looked at things like when an individual's living condition changes. So the values, the underlying factors don't change, but their particular values on those factors change. Or what if there's like someone showing up and they look a lot higher risk than what they're putting in their app regularly, maybe because they just don't want to drive in. What do you do? How do you disambiguate? And then the last one was a data sharing thing. So again, this took less than an hour to run through with these are summaries of the questions. Each inject had like 5 or 6 questions. And what we found was we had in an 90-minute total thing, we had 15 user stories. We had resilience engineering experts code them, and 13 of the 15 were relevant. They were things that we wanted. The other two were just like good features, which again I would argue is not a bad thing. We're still hoovering up a lot of useful information. Um, we also identified new users and stakeholders. So again, this was a development focused TTX, but like I said earlier, we had all these kind of research findings as well. So whether you want to do one or the other, you're kind of going to get both. And so what we found was, the family of the patients is a great source of data. The chief medical information officer, the clinical decision support team, they're all players that weren't currently represented by any user stories. They weren't considered factors and they weren't being considered in development of this technology. We identified new ConOps. So in a non-military context, we defined ConOps as anything that's not actionable, a finding that's not actionable by a software engineer, or else it would be a requirement. But there's some way you could deploy, administer, maintain, etc., the system that would have an impact on its success and on the resilience of the sociotechnical system. And then we got subjective feedback, only 5 people. But again, if you want to look at glass half full, 5 of 7 is a pretty good response rate. But we did this pilot study and we did surveys right after the TTX. So before they ever saw any results. And after we delivered those user stories in this product, we then did another survey. And the big outcome or big result was we developed this exercise protocol, which I believe is publicly available. And so these are just again hit some of the wave tops here. Some of the things that I really like again is like about things we know about war games and TTXs is it made people agreed it made them think differently. There's a lot of comments like, man, we didn't consider any of this stuff. Like I said, they discovered entire new users they weren't considering. They're able to discuss and uncover assumptions. Again, I talk about being fun. They were engaged. They're like, yeah, I would regularly do this. There was some doubt about whether they could do this themselves without our help facilitating, which was kind of a ding on us because one of our goals was to make this turnkey so anyone without expertise can do it, which is a tall order. We had 2 questions that we asked in both surveys. So, is it effective? And do you think you'd want to do this regularly? And so we got pretty decent feedback on that. And then when we gave them the brief, we gave them their user stories and the outcomes of it. Yeah, they were satisfied by the quantity, the novelty. The novelty to me is the one that I really like looking at. These are things that I would not have thought of otherwise. If we didn't actually get into a scenario and invite some clinical experts and like some users and stakeholders, we never would have thought of this. Again, efficiency, the things they disagreed with was for the same time and effort, could you have gotten more things out of it? Could you have gotten more novel things out of it? And there was a largely negative, no one was even neutral. And people were satisfied with the products. And again, these answers shifted to the right a little bit. They got more positive. So they already thought it was pretty good, but kind of a trick question because you don't know if it's effective for generating user stories. Once they saw the results, they thought again that it was effective. So just wind it up here for discussion. I hope folks have some questions here. I'm tired of talking, to be honest. Um, so some key points, just things I want to hammer on real quick. So again, if you take nothing else from this talk, what I'd like to impress is that war games, tabletop exercises, etc., they're a really elegant and context-rich way to examine different social and behavioral phenomenology. They give you relatively, not totally, but relatively naturalistic settings. There's so many different mechanisms for inquiry we talked about. You can collect data in so many ways. So if you're a social scientist, you need to be working with war gamers. You need to be working with tabletop exercises. Stop doing surveys asking people hypothetically or prospectively what they think would be important or how they would do something. Get out there and actually kick the tires on that. Again, second one, social scientists can come to the table. They can increase the rigor, the quantity, the quality of insights that you glean through your games and your TTXs, and that's different mechanisms like bringing to bear relevant constructs, methods, measures. We talked about that, measuring squishy stuff. Treating the game like an experiment. Again, helping just map out and scope, everything from your high level objectives to specific research questions to hypotheses to tests to data. Doing all of this. This is all secondhand stuff that we do all the time. And then again, like to come back to my first point, really, this is restating the first point. War games are a really underutilized medium for human factors engineers, systems engineers. If you want to understand human decision making and cognition, if you want to design human centered technology, war games and TTXs are an invaluable way of doing it, and I think they're incredibly underutilized. And so this is kind of like me trying to play matchmaker. I really believe that social scientists and wargamers, OR folks, need to be working together much more tightly because you get a lot of these neat things and applications that have shown success. And if you were thinking, Steve, the talk was great, but I prefer to, intake information through dense, refereed scholarly literature. I have a treat for you. Um, Again, I'm a mid-career social scientist. I'm very happy to share papers with you. So, the RAD-XP thing is in here. That actually tells you a lot about what we did. The guidebook, I believe, is also the actual protocol is publicly available. Um, there's that paper on it, the value of war games. The second one that talks about Sage Dragon and some of the things I talked about, like soft benefits and the R and the D, research and development benefits. So if you want a paper to cite saying why like war games are a good thing, that should be a ready to go thing for you. The Wake paper is in there, talk about some of those methods, all those images I showed, the ways to sort data, all of that's in there. The Going Digital paper, that was the case study about making a digital thing but losing kind of some of the conversation. And then the tough cell resilience engineering end is less relevant, but one of the papers that talks about how we need proactive, lightweight, participatory methods to do cognitive engineering, resilience engineering, etc. So I'll go ahead and stop there. And there's my con. You can find me on ResearchGate. I can send you papers on ResearchGate, LinkedIn, whatever. But yeah, I'll just stop there and see Sebastian if there's any questions or anything going on.
Steve, great presentation. Thank you. And you know you're a scholar when you have to mention ResearchGate in your presentation, like a sponsorship. We have some questions. So the first question I have is barriers to entry. You mentioned folks being able to do processes like this on their own, and I and others are trying to get our initial attempts on the board. What are some low-hanging fruit low-hanging fruit was there to get at? Trying to develop some other than more serious games for cracking the nut on topics internal to begin with.
So if I may or may not understand the question, if I don't answer it well, just call me out. We got plenty of time. So I think again for me, yeah, TTXs are pretty low hanging fruit. And at the risk of trying to democratize things, I don't want to make it sound like anyone can do it because there is a lot of expertise in how these things can be done well. Um, some low hanging fruit, I would say, was like when we did the RAD-XP thing. There's a lot of existing in that case, it's a TTX to design or develop some kind of technology. Um, I think that there's a lot of existing documentation, like there's ConOps documents, there's system requirement specifications, system design documents. We were able to take a lot of existing things and just kind of make it into a scenario-based thing that help people explore. So um, I would say that those are kind of, TTXs are kind of a low-hanging fruit in and of themselves. And then within that, you can kind of get away with designing those and developing those without too much of a lift because a lot of things that we would use to make those already exist in most development processes. Um, Trying to think. I don't know if that answers the question.
So, for those who are unfamiliar, could you define what's the difference between a TTX and other forms?
Yeah, so I should be able to answer this hopefully with all the Morse training. But yeah, there's a great paper that Caffrey wrote that I like to cite when I talk to colleagues because TTX and Wargame get used interchangeably all the time, right? People say they want a TTX and what they really want, they're like, they talk about calculating, PK on things, and it's like, nope, that's a Wargame. But yeah, I think the definition is a thinking adversary. So a TTX, regardless of the actual medium, it could be, I think in the paper, Caffrey talks about it could be, thousands of troops in a field with live fire ammunition. But if there's no thinking adversary, if you don't see the consequence of the decisions you make that are manifested in the subsequent turns or later in time, if it's pre-scripted, it's a TTX. And vice versa, we play a lot of war games on a tabletop. So again, if you do something, and whether it's AI or it's other people or some combination, if the things that you do as a blue player, as the as yourself, if you do something and there is a reaction, the thing that happens next is dependent on that, then it is a war game. That's the definition that I tend to use. Although again, I said I'm not a war gamer, so I feel a little bit bold making that assertion in this crowd, but that's what I'm going to go with.
That's great, and you're right. DoD and the wider government tends to use TTX in games pretty poorly in terms of like keeping the distinction. I know some sponsors who have insisted on something being called a TTX, and sometimes that is organizational because their boss expects something to be called a TTX, so they call it a TTX regardless of definitions and purpose. Um, so another question is, when examining the introduction of additional technology, do you think through a larger sample size or different demographics would change the naturalistic decision-making processes that you observed?
Yeah, definitely. I think just to tap on that last question real quick too is I don't think it matters so much if a sponsor wants to call it one thing or another. I don't think that's particularly important. I think the more important thing is just to talk to them and really figure out what it is they want, right? So it's like you can call it whatever you want. I'm happy to do that. We just want to make sure that we have, we make you the right thing. But to the other question, yeah. Again, NDM is based largely on expertise, right? So, again, if you're doing something for the military, you'd want to get those actual people the right rating, or MOS or whatever you want to, whatever branch of service you're working with. And yeah, if you have different people, you'll get different things. So again, going back to like say submarines or even surface navy, if you do games, the same exact thing, but looking at technology with Atlantic versus Pacific Fleet, you'll get very different things because they have different types of missions, different ways they work with allies. There's different allies, different adversaries, different operational environments. So yeah, I would say absolutely, and even within certain ratings of say like submariners, you'll get very different ways people employ technology, whether they're land or pack, for sure.
So someone asked, could you go back to the RAD slide and talk a little bit more about how that process works?
Yeah, sure. I assume it's this kind of blocky one right here. Yeah.
Yeah.
Is there a particular step or phase that there needs to be more detail on?
I think their question from my observation here is that could you walk through like what does the RAD-XP like get you in terms of like if I was going to use RAD-XP internally?
Yeah, so it actually has explicit guidance on how to do every single one of these things. So it'll tell you, again, we have a table that says here's the types of documents to ask them for when you want to explore the technology. Like, is there a request for a proposal? Like if you're building something, someone probably you proposed it. There's got to be a call for proposal somewhere where they state what the problem is. So it'll walk you through specific interview questions and documents to look at for sense making one, sense making two. It includes a template for a measle, a master scenario event list. It includes a template for writing scenarios, the overarching global thing. It has an appendix with 10, 15 different archetypical scenarios like sunny day, most dangerous, most likely, like down for maintenance, a day without X. Like if you're running all of our examples use an ice cream shop. If you're running an ice cream shop, a day without X might be what if the internet's down and your point of sale doesn't work? So we tell you how to write scenarios. We tell you how to write injects. So what interview questions to ask users and designers or engineers. Then based on their responses, how can you turn that into a cohesive set of injects? And then for each inject, we have guidance on how to write prompts, like the specific questions you ask them to respond to. We have guidance on how to do even like the kind of best practices. Like again, if you're a novice to TTXs, we have guidance on like general ways to facilitate facilitation best practices, how to give an introduction, how to run a hot wash. We have pre-canned hot wash questions you can take and adopt. So like I said, it's like a 40, 50, 60 page document. But it has a turnkey thing. It has templates in here for everything from the scenario event list. It has example injects or archetypical injects like competing goals, like introduce competing goals, or introduce conflicting information that may look like something completely different for a medical thing game versus a military game versus an intelligence game. But we have these kind of explanations of everything, step-by-step instructions, but we also provide kind of like archetypical examples that you can then take and kind of mold into what you're trying to do, no matter what your domain is.
So could you go back to the slide, I think it was your conclusion slide right before your name and bio stuff and this one. So war games as with games with social scientists. So there's a broader movement in academia about using games as like social experiments, right? To create generalizable sort of political science insights. What are your thoughts on that?
I agree with that. I mean, I think several slides back, like I said, it says it here, treat the game like an experiment. And I think I said it earlier on too. That's one of the ways that why I think psychologists are naturally helpful is, if you have it beaten into you in grad school that like you need to treat everything like what are your independent variables, what are your pseudo variables, what are your dependent measures, you know, um, what are you going to analyze, what data will you collect, what will you do with it, like games are a great way to be an experiment. I absolutely think so. And again, like as an NDM guy, I'm loath to ask people to speculate. It's so much better to, in my opinion, to die. And there's a place for that stuff too. Don't It's not either or, but yeah, I think that games are again, um, I think Perla. I think there's some quote somewhere I wish I were able to recite, but the kind of the point or the value of games is the interaction of human cognition or human decision making with game elements. So if you want to study how technology will change something, how manning or tactics will change something, how people will behave, how teams can form, how teams can change. To me, I think there's just this wildly diverse set of applications for war games and TTXs, and I think that more social scientists should be doing this. Absolutely.
So they have a follow-on question. So I'll try to summarize. One of the questions is, how do you manage the plethora of variables inside a war game, right? And some of the critiques for some academic experiment, social science experiment games is that they try to reduce the number of variables by reducing the level of agency for players. And how do you get around that? I think I characterize that well. If I didn't, please message me. Sorry.
Yeah, I think that's a common thing. And my biggest thought would be figure out which ones matter. So again, going back to again, start. What are your research objectives? What are what is the overall objective? What are research questions? So again, like it's kind of like a meeting in the middle where we all know like war game is like our small n, right? So from an experimental psychology perspective, people will be like, oh, coming out of school, they'll be like, yeah, like I need 60 people, I need to run this 60 times for a between subjects design with this estimated power, and that'll get me my answer. But it's like, no, like we had to fly in 15 people from across the country to do this. We're gonna get 2 reps in. We're gonna do it twice in 3 days. Especially like for strategic games, right? Strategic games might have like half day turns and adjudication. And so if you only get 2 looks, you might say, okay, well, what are the variables that really matter? Is it a baseline? Is it worth baselining it, or do you just assume that like everyone will have these other things? Um, I think it comes down to also just capturing stuff. The more things you capture, the more the more you can contextualize the findings. So I think you have to kind of wrestle with the fact that you can't control for everything, but that's also kind of the beauty of it. But you need to figure out what things are being done. That's why in the Wake thing, I like capturing assumptions as well. So if you only get to do it, like in that case for Wake, we did it twice. We had two crews, if you will, over 3 or 4 days. Um, and basically, we said, okay, like things are going to vary. We had them do kind of the same, the same. Actually, I think we did different missions. So again, yeah, we couldn't even control. So it's like, well, I want 2 or 3 looks at the same mission, but you can't. You have to do different things. So I think it just again comes down to identifying what your objectives are, what your research questions are, and then figuring out what things you might want to intentionally vary between, because war games are small n.
So I have one last question, so I'll encourage anyone else to pop in any last questions is what are some challenges you've encountered in integrating social science techniques into gaming or TTXs?
Oh man. Um, a couple things on both sides. One is convincing people that social sciences matter or that qualitative things matter. Like I said, you get people who are like, yeah, I just want to like have them answer a number from 0 to 100, then I'll take the average, the mean of that, and then I'll report that. And it's like, no, please don't do that because that's not valid for you don't even know what construct you're talking about. But people will often look at, especially qualitative research or subject, as subjective or not official or not real. So I think some challenges have been like, hey, like, you know, you don't need to do all this, numeric based stuff that doesn't actually get at the point. It's hard to say, hey, we know what we're doing and we can help you. To that point, I think that also, as I mentioned earlier, alluded to, was I think a lot of folks on the social sciences side don't do a good job of concisely or effectively explaining the value. So part of that is on us. I think there's like a bit of an ivory tower thing where, like I said, they'll be like, well, to really get at this construct, we need a sample size of at least blah blah blah, and it's like, nope, that's not how this works. That would ruin the mechanics of the game. You have to be willing to get off come down from the ivory tower, meet people where they are, and do some kind of quick and dirty science. So I often think, to be a little bit introspective, that social scientists don't do a great job explaining why what we do matters. And that's, to me, how I rate, in my opinion, how good a social scientist is how good they are to explain to non-social scientists why what we do can help them. And not everyone's that great.
So I have one last question. Oh, two last questions. So what are the strengths of TTXs and war games in hybrid gray zone and military operations other than war? I'm surprised I remember exactly what the acronyms stand for in developing strategic thinking.
Um, well, I would just say philosophically, coming from a hypothetical perspective, I would say that again, you can try a lot of stuff. So, I am relatively new to Matrix Wargames, and I'm a huge, love at first sight. So again, coming from more of a Kriegspiel tactical background, I do think Matrix games are great for those who may not be familiar. Blue, red, pretty much make arguments. They say what things they're going to do. They make arguments about why it'll be effective or why it won't, and they kind of get to point counterpoint. The white cell can take that argumentation into account. Um, and so when you have less rigid structure, like you're doing kinetic force on force stuff, things like TTX is like a seminar style game, or a TTX where you discuss it, or a matrix style game where there is a thinking adversary, but it's based largely on the argumentation. It forces you, I'm big on metacognition, right? Thinking about thinking. It forces you to think about what you know, what you don't know, and forces those important discussions. And again, people don't game for the results. You don't say, well, this worked out. This is what we're going to do in the future, right? You do it to discover things and to think and change the way that you think. So I think that TTXs and war games are great for these kind of squishy things without such clear defined cause and effect relationships, or at least easily modeled cause and effect relationships.
So I have two more questions, which is what hands-on tool aids seem to help time and time again while running games?
Oof. I don't know. I've done a wide variety of things, so I don't know if I use any specifics. I would say probably a watch. Super anticlimactic answer. I don't have a whiz bang cool thing to talk about. I know, at the risk of sounding like, proselytizing at MITRE, we have a thing called Case, which is, I think, fantastic for, it automates a lot of stuff. It helps with data collection. It has a chat client. It helps play cards or play levers. You can queue them up as players. You can hide stuff, single blind, double blind. I'm a huge fan of that tool. I wouldn't say I've used it time and time again, but a watch. I think a lot of things, if we're not careful, things can get away from us. And so I think honestly, just keeping time is one of the hardest and most important things to do. I don't know how many times I've seen games or TTXs planned for 6 rounds and do three. And we got good stuff out of it, but we could have gone further. So I would say my watch is probably my favorite tool.
So the next question says, after exploratory wargamer TTX, have you done follow-up exercises to validate the finding? And if so, is that done by rerunning the exercise or setting up something new that could disconfirm the findings?
Yeah. So the answer, I would say it depends, but yes. At some previous stuff we were doing again, um, kind of interspersing. We did what we call a campaign, right? A campaign of games. And what we did was, a thing that I thought was wildly effective was, we would do these kind of like design thinking events where we would, have people, doing all the sticky note driven innovation, divergent, convergent thinking and coming up with concepts, for, whether it's hardware, sensors, weapons, software, tactics, whatever. We would do these events and then take some promising findings from them or things that people voted on. We would then explore them in a, we'd have a week where we do, 3 rooms, a couple games, 2 games a day, and we would do a week of that. We'd have, 18, 20 games in a week. Um, and then we would take the results of those games, figure out which things need to be pruned, and then come back and frame the next kind of design thinking innovation event based on the findings. So we had games and these kind of brainstorming and voting activities that were going in and out. We had games every 3 months, and so we'd have different parts of the warfighter community come in, and yeah, and sometimes we would retest things. Say, did you just get like a lucky dice roll last time? Or is this generalizable? And sometimes it'd be whole new things. But I think combining games with other analytic processes, we were running modeling and simulation runs. We would do 1,000 reps and say, "Hey, that was a lucky dice roll." In reality, this gets crushed like 80% of the time. So I think the power is in combining games in bigger campaigns with other participatory methods as well as like modeling and simulation.
So, Steve, while I wait for any last minute questions, I want to thank you on behalf of the Georgetown University Wargaming Society for your expertise and your time and sharing your experiences with us. It's always great to highlight the work that people are doing across the field because one of the things we struggle with always in DoD is horizontal visibility. And you can see a bunch of people thank you in the chat. So from us from Georgetown, thank you for spending the time your Tuesday with us and sharing your expertise.
No, my pleasure. Thanks for having me, and thanks everyone for listening to me talk for an hour and a half on a Tuesday night.
All right, appreciate it.